This is section 4.4, and we have discussed two objectives up to now, and both objectives were about how to solve exponential equations, sorry. And we mentioned that there are two methods to solve exponential equations. First, you try to write both sides with the same base. You try to have the same base in both sides. If you can do so, you solve it like this. Okay, then the base, if the bases are the same, then the powers are the same, and you solve the equation. If you can't, you apply len to both sides, or log. If the base is 10, you apply log to both sides. Today we will discuss logarithmic equations. And logarithmic equations are equations in which you see a logarithmic function containing a variable in a logarithmic expression. So you see a logarithmic expression in one of the sides. For example, this one. This is a logarithmic equation. Also, this is a logarithmic equation because, as we all know, ln is log to the base e. So ln x would be log x to the base e. So it's a logarithmic expression. So this is a logarithmic equation because there is an equality sign. Okay, there is an equality sign. Okay, so how to solve the logarithmic equation? Well, we will take two methods. Again, two objectives, two methods. The first one, we will use exponential form to solve logarithmic equations. So we will change the logarithmic equation from the logarithmic form into the exponential form. That's the first method, and it's the easier than the other one. So use the definition of a logarithm to solve logarithmic equation. What is the definition? Remember, that's the definition. That's what we studied before. We said that if you have log m to the base b equals to c, this equation, logarithmic equation, you can write it in an exponential form as b to the power c equals m. So b, which is the base, you raise it to the other side, b to the power c equals to m. So you change it to exponential equation and then you solve it. Okay, that's the method. But first, the first step, these are the steps. The equation has to be written in this form and exactly in this form, which means if there is a number in front of log, and if the equation is 3 log m to the base b, you cannot use number 2. You cannot use the definition. What should you do? You have to get rid of the 3. You have to take it up using the power rule, as we shall see in the exercises. So first, you express in this form. Second, you use this definition. Third, you solve for the variable x. And fourth, you have to check your solutions. And this is very important. You have to check the solutions here in the logarithmic equations always. Why? Because the domain of the logarithmic equation says that m must be positive. So what is inside the log must be positive. So if your solution does not make the expression inside the log positive, you have to remove it, not to accept it. Okay, so let us, bismillah, take one of the examples. This is a logarithmic equation written in the form log m b equals c. So immediately we change it to this form. So we will have x plus 3 equals 4 to the power 2. Finished. This is a linear equation. You solve it and you find the value of x. This is 16. You take 3 to the other side. So x is 13. Now the answer is 13. You have to check this answer. Now if you replace x in the original equation, this is the original equation. You go to the original equation, which is this one, and you replace x by 13. So you log 13 plus 3. Is it equal to 2? Should be equal to 2, because the equation says it should be equal to 2. Log 16 4, you calculate this by the calculator, or you think 4 to what number equals 16? 4 to the power 2 equals 16. So log 16 4 would be 2. 2 equals 2. This is true. So the solution set is 13. So 13 is correct, and 13 is the answer of this equation. Here I have a problem in this question. This 3 is a problem, okay? Because the equation should be written in the form log MB equals C. But here I have 3. So what should you do first? You should divide by the 3. Okay, so first we divide by 3. So once you have it like this, without 3 before the len, now we can change it to the exponential form. Okay, remember, len is log to the base e. You can write it like this if you want. It is not necessarily. If you understand that the len is log to the base e, you can immediately from here write e to the power 4 equals to 2 to the power x. But if you want, you can write len as log to the base e, and then you use this formula. So e to the power 4 would be equal to 2x. And now you solve the equation for x, you divide by 2, so that's the solution. The solution is e to the power 4 over 2. Now you have to check this solution whether it makes 2x positive or negative. You replace x by e to the power 4 over 2. If you multiply by 2, 2 cancels with 2, and you get len e to the power 4. Len cancels e, if you remember, and you get 3 times 4. So 12 equals to 12. That's true. So the answer is e to the power 4 over 2. That's the solution set. Well, for this equation, which is the first equation here, to check that the answer is 13, graphically, you have two functions here. The first one, log x plus 3 to the base 4. This is the first one, log x plus 3 to the base 4. And the second one, 2y equals to 2. The solution of this equation, would be the point of intersection between the two graphs. So y equals to 2, this is a horizontal line. This is a horizontal line, y equals to 2. And y equals to log x plus 3 to the base 4 is a logarithmic function shifted 3 units to the left because of the plus 3. So the vertical asymptote would be x equals to negative 3. It would be here. The vertical asymptote would be here. X equals to negative 3. So that's the logarithmic function. Where is the intersection point between the logarithmic function and the horizontal line? It's when x equals to 13. So that's the solution of this equation. This is how to solve this equation by the graph. Okay. More exercises. How to solve this equation? Immediately I change it to the exponential form, and I continue. X would be 2 to the power 3, which is 8 plus 4, 12. And now you have to check your answer. So 12 minus 4 is in fact equals to 3. It would be log 8 to the base 2 equals to 3, and that's correct. So the solution set is 12, which is the answer. Here you divide by 4 first. So you will have len 3x equals to 2, and then 3x would be e to the power 2, and x would be e square over 2, and you have to check your answer. Checking your answer by changing x to e square over 2 in the original equation. Okay. Now you cannot stop. No questions now, please. So you cannot do anything here. Okay. Now this is 3x equals e to the power 2, e to the power 2 over 3. Sorry. Okay. So this is 3, not 2. And here you have 3. I think you wanted to say this. فالآن we cancel 3 with 3, and you will have 4 ln e square. Now ln cancels with e, and you have 4 times 2, which is 8, which is equal to the right hand side, so it's correct. So the solution set is e square over 3. طبعا if you did not pay attention, if you make my mistake and you wrote e square over 2, you will find that by checking it will not give you 8, so you understand and you did a mistake. Now, an important question, and please pay attention to this question. Can a negative number belong to the solution set of a logarithmic equation? Can the answer here, x, مثلا x equals -1? Could the answer be negative? And the
No.
answer to this question is yes, 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 yes. And here is an example. And please pay attention to this because this is an important question. Okay, this is an equation. Okay, change it to the exponential form. So 2 to the power 3 would be x plus 20. This is 8. Taking 20 to the other side, x would be -12. Negative number. Is it a solution? Let us check. Let us replace x by -12. We will have log -12 plus 20, which is log 8. Log 8 to the base 2 is 3. That's true. So the answer is -12. So what is the problem? We did not say إنه الأنسر cannot be negative. We did not say that. What did we say? I said what is inside the log. What is inside the log cannot be negative. X plus 20 cannot be negative. So x here -12. -12 plus 20 will not make it negative. It will make it 8. So -12 is accepted, okay? Because -12, although it is negative, but it does not produce the logarithm of a negative number. So the problem إنه x plus 20 تكون negative. Notice that the domain of this expression, what is the domain? إنه x plus 20 should be greater than 0. So x should be greater than -20. So the domain is from -20 to infinity, and any number greater than -20 would be accepted as a solution. -12 is greater than -20, and that's why it's accepted as a solution. So please pay attention to this point. Answers could be negative, but the problem, what is inside the log, cannot be negative. Now let us go to some other types of examples. I have a problem here. I have two logs, log plus log. What should I do? Well, you have to write it first in the form log mb equals c. You have to write it in this form first. How can I write it in this form? I have two logs. Yeah, remember we studied condense. You can condense these two logarithms. You can write them as a single logarithm. How? By using the product rule, because log m plus log n equals log m times n. So log x plus log x minus 7 can be written as log x times x minus 7. And now you have one log, so you can use this fact and change it to the exponential form. So x times x minus 7 would be equal to 2 to the power 3, which is 8. You expand, you have x squared minus 7x. This is a quadratic equation, degree 2. So you have to take 8 to the other side. You have to leave one of the sides 0. And now you have x squared minus 7x minus 8 equals to 0. You solve this quadratic equation. Try by factoring x times x. You search for two numbers. Their product is -8 and their sum is -7. The numbers are -8 and 1. -1 times 8 times 1 is -8. -8 plus 1 is -7. So this is the factored form. So either x minus 8 is 0 or x plus 1 is 0, which means x equals 8 or x equals -1. Let us check our two solutions. These are proposed solutions. We need to check. Let us check 8. Okay, so go to the original equation. This is the original equation, and we replace x by 8. Of course, here, by looking to the equation, if you just look to the equation, you understand that -1 is not accepted. Why -1 is not accepted? Because it will make the first log impossible. Log -1 to the base 2 is not defined. I cannot find log -1. So -1 is not accepted in this case. But let us check. So log 8 plus log 8 minus 7. Now this is 8, this is 1. Log 1 is 0. So log 8 to the base 2 is 3. So 3 equals to 3. This is true. So the first solution, 8, is correct. Let us see -1. If you replace x by -1, this is not good. Number one, -1 does not work because the domain of this function is all positive numbers. It cannot be negative. So the answer is only 8. The solution set is 8. Let us solve this equation. I have two logs here where the base is 10. So log, I can use the product rule to write it as log x times x minus 3, and the base is 10 equals 1. Now I have one log, so I change it to the exponential form. X times x minus 3 would be 10 because the base is 10 to the power 1. Then x squared, so let me write power 1 here for you to remember. So x times x is x squared minus 3x minus 10. You have to take it to the other side because you have a quadratic equation. Now to factor the quadratic equation, I have x here and x here. And now I need two numbers. Their product is -10 and their sum is -3. I can think of -5 and +2. -5 times +2 is -10. -5 plus 2 is -3. So either x minus 5 is 0, which means x is 5, or x plus 2 is 0, which means x is -2. If you check -2, it's not accepted because of this. So -2 is rejected since log -2 is not defined. Okay, while if you replace x by 5, you will have log 5 plus log 5 minus 3. Okay, and this would be log 5 plus log 2. You can use the product rule. It would be log 10, and log 10 is in fact 1. So the solution set would be 5. 5 is the solution, and -2 is rejected. Another example, please try to solve this example by your own same method. You follow the same method like the previous one and check that the answer is 5/4. These also questions about the same objective from the book. This is easy. X plus 25 equals 2 to the power 4 immediately. This is also easy. You have to divide by 5 as we solved two exercises similar to it. Here you change it to product, use the product rule, condense, and you continue. Here, let us solve question 71 because it has a quotient minus. First, we have to use the quotient rule, log, to change it to condense, to write it as a single logarithm. So we'll have log x plus 2 over x minus 5 all to the base 2. Okay, equals to 3. Now I have one log in the left-hand side, so I can use the definition to change it to the exponential form. So x plus 2 over x minus 5 would be equal to 2 to the power 3, the base to the power 3, which is 8. Now to solve this equation, I multiply cross product. So x plus 2 times 1, I will have x plus 2 times 1 equals 8. 2 to the power 3 is 8 times x minus 5. So I will have 8x minus 40 minus x minus 2 equals 0. I will have, I shouldn't do it like this. Okay, let me It is okay to do it like this, but I will do it in another way. 8x minus 40 equals x plus 2. This is a linear equation. It's not quadratic, so it's very easy. Take x to the other side, so you will have 7x. Take 40 to the other side, you will have 2, and your answer would be 40 over 2 over 7, which is 6. So 40 over 2 is 6. So the answer is 6. Now check your answer. If you check it here, 6 plus 2 is 8. This is good. If you check it here, 6 minus 5 is 1. That's good. It would be correct. Okay. But you have to show him your steps. Log 6 plus 2 to the base 2 minus log 6 minus 5 to the base 2 equals. Now this is log 8 to the power 2, which is 3, and this is log 1 to the power 2, which is 0. So the answer is 0 plus 3, which is 3, and the solution set is 6. Here, let us solve 73 because we have two problems. We have 2, and we have log to the other side. Well, first thing I have to do here, I have to take, I will write it like this: log x plus 4 to the base 2 using the power rule. Okay, and then I take log, well, log 9,3. This is log 9,3. That's easy. What log 9,3? What is log 9,3? Log 9,3 is 2, because 3 to the power 2, 3 to the power 2 is 9. So this is in fact 2. So that's easy. You have 2 log x plus 4 to the power 3 equals 4. That's it. You have to divide by 2, and you can continue easily. Okay, so the log x plus 4 to the base 3 would be 2, and you continue. You write it in the expression, in the exponential form, and you continue. Here I have 3 logs. No problem. Condense. Write it as a single logarithm. If you write it as a single logarithm, I have, of course, you have the base the same base. If the base is the same, then that's good. If the base is not the same, that's a big issue. So the base is the same, so we write it, condense it to one logarithm. What should you do? I have x minus 6 with a positive coefficient, so it should be here up in the numerator. I have x minus 4 with a positive coefficient, so it should be up in the numerator. I have x with a minus sign before the log, so I have x below here. That's the product and the quotient rule together equals 2. Now I change this log to the exponential form, so I will have x minus 6 times x minus 4 equals over x, okay, over x equals 2 to the power 2. If you multiply cross product and also expand this one, so I will have x squared minus 6x minus 4x, you will get minus 10x plus 24 equals 4x. And now you can take 4x to the other side because this is a quadratic equation. So I will have negative 14x plus 24 equals to 0. You try to solve this equation by factoring x times x, and you search for two numbers. Their product is 24 and their sum is 14. Well, 2 times 12 is 24. So negative 2 times negative 12 would be 24, and negative 2 plus minus 12 would be minus 14. So either x is 2 or x is 12. Now you have to check both answers. Notice that x equals to 2 is rejected. It is not accepted. Why? Because if you replace x here by 2, you will get 2 minus 6. That's negative 4, which is not defined. So x equals to 2 is rejected. It is not good. It is not accepted, although it's positive. But the problem is not being positive or negative. Our problem with this, with log x minus 6, it should be defined. So log 2 minus 6 is not defined because it would be log negative 4, and this is not defined. So let us check 12. So log 12 minus 6 to the base 2 plus log 12 minus 4 to the base 2 minus log 12 to the base 2 equals, okay? This is 12 minus 6, this is 6. So I have log 6 to the base 2, and I have 12 minus 4, this is 8, log 8 to the base 2, and I have here log 12 to the base 2. You can evaluate this either by the calculator or by changing it, by condensing it. So I have 6 times 8 over 12. You can cancel 6 with 12 and you will have 2 here, and then 8 divided by 2 is 4, and in fact you will have log 4 to the base 2, and this is 2, so the answer is correct. So the solution set is 12. Well, I'll stop here. Objective 3 is good for today, and let us stop here and take your questions.